Again, Pumchusi, and it's my pleasure to be your MC for this morning. It is indeed a great honor to have all of you here in this seminar to share and discuss about the challenges, research, and practical solutions in advancing the transportation and logistics in Thailand. For today's program, we are in the theme of the advance in transportation and logistics research. And before we start the program this morning, I would like to invite Associate Professor Dr. Siriporn Damrongsagun, the Associate Dean of Engineering for Research Affairs, Chulalongkorn University, for a speech to officially open today's seminar. Please welcome Associate Professor Dr. Siriporn Damrongsagun.
Distinguished guests, ladies and gentlemen, colleagues and students, today it is my pleasure to be here this morning, and on behalf of the Faculty of Engineering, Chulalongkorn University, I would like to welcome all of you to my campus, to our campus, and also to today's event. The symposium today is entitled Industrial Logistics and Transportation in Thailand, Challenge, Research, and Practical Solutions. The event today is organized by the Center of Engineering Logistics, which is supported by Chulalongkorn University 100 Years Fund, in conjunction with the Ministry of Science and Technology, the Royal Thai Embassy in Washington, D.C., and Sirinthorn International Institute of Technology, Thammasat University. The Faculty of Engineering organized its research activity into 6 clusters, and in infrastructure and logistics is one of the major clusters. We aim to develop research and knowledge in this field in hope that they will be disseminated to wider circles and adopted by industry. Through these synergies, relevant progress and development of Thailand would be made, and benefit would be shared amongst all parties, including Thai society and Thai economies. The objective of this event is to disseminate technology and development of basic applied research related to logistics system and transportation to faculty staff, researchers, and practitioners from both public and private sector. So for the event, for this event, it is organized in 2 days for 2 groups of audience. Today, we aim to provide recent advancement in the field of transportation and logistics, primarily to academic audience. So today, we are lucky to have distinguished speaker from internationally renowned professors from the United States and Korea and South Korea. And for tomorrow, we are fortunate to be able to invite key industry magnates in the field of supply chain and logistics to provide keynote speech to a larger group of audience, including academics and industry practitioners. The theme for tomorrow is highlighting the success of applying research knowledge in practice and also to finding ways to encourage more knowledge transfer into practice. So I urge you to please take this opportunity to share and listen to the speaker and share your views. I look forward to fruitful exchange of comments and ideas during these 2 days. And if there is any assistance you may need, please feel free to let me or our staff know. I think it is now the time, so please please join me to let the symposium comment. Thank you.
Now we come to the first talk. It's my pleasure to introduce all of you our first speaker, Dr. J. Krishnan. Dr. J. Krishnan received his master and doctoral degree in civil engineering from University of Texas, Austin in 1992. He is now a faculty member and associate professor of civil and environmental engineering at University of California at Irvine. He specialized in the area of transportation systems engineering. Dr. J. Krishnan's research involves the study of dynamic traffic assignment and simulation for advanced network informatics. He's also working on system performance and user response using real-time information in congested traffic corridors. In today's talk, Dr. J. Krishnan will share with us his research in the modeling and planning processes of port, freight, and traffic interaction. Please join me in welcoming Dr. J. Krishnan.
Thank you for welcoming me here. My name is J. Jayakrishnan from the University of California at Irvine. First time that I'm coming to Thailand, and already saw the traffic jam, so I'm happy. I had always heard, as a transportation engineer, it's a dream to come and see the traffic congestion in Bangkok. You always hear about it till you try to get out of the hotel and see everything packed and stopped. You don't realize that. So I'm finally here, and I'm glad to be here. I have the bad job of doing the first presentation. My tendency as an academic researcher is to get into the nitty-gritty details of the topic and show optimization algorithms and all of that. I tried my best to curtail that tendency and just take out every equation that I could find in my slides, which I did last night after I flew in at 9 o'clock after a 36-hour flight from Los Angeles, so I'm jet-lagged too. So if none of my slides make any sense and suddenly equations show up, please excuse me. So I'll try to give a keynote speech where hopefully there are some key items to note. We'll see. So the main theme matching the topic of the workshop is this. Industrial development, as you see around the world, the first thing that happens is there's increased freight traffic, which is automatic. Trucking is usually what picks up first, and the trucks end up on the roads. If the infrastructure is not there or if it is not adequate, you will have problems, which is well known. Perhaps what is lesser known is that in fully industrialized countries also the problems are very much there. USA is a classic example, and I will give the example of the Los Angeles Long Beach port, one of the largest port complexes in the world, and the connected freeway system and what issues come up, and the kind of modeling that we try to do over the last few years, a variety of projects connected to it, and I'll pick and choose a bunch of different items to illustrate the kind of issues and the kind of modeling that can be done, and hopefully some items worth thinking more about might emerge as we do that. So the question is, how do we model the true costs of freight traffic as it interacts with the regular traffic and causes externalities such as pollution, health issues, delay costs, accidents, injury, deaths? These are all possible. What can traffic modeling play? What role can traffic modeling play in this? Our planning models are adequate, or more detailed simulation needed? That's the question that we face. So as a motivation and a set of objectives, how serious are the issues? The main issue is, of course, traffic congestion. At least that is the the particular topic that I am focused on in connection with the freight movements in the networks. Of course, there are very involved issues of economics, location of industries, several other topics that will come up with it. But just focusing it down to the issue that a transportation or traffic researcher would look at, the problem presents itself as traffic congestion and air pollution that comes from it, and public health. And the third issue of public health is usually not looked at in all that much of details. And in fact, some recent research that we did that I'll present, one of the first cases where this was looked into at some detail, and the interesting results can come out of it. Can we mitigate traffic congestion? Can it reduce air pollution? Those are the questions. And how do we evaluate these kind of problems in a large network and develop an integrated evaluation framework to study it? That was the issue. Let me present the context of it. As you can see out there, that's the map of the network that we are talking about. In this area, you have two large ports, pretty much side by side, the Los Angeles port and the Long Beach port. So the whole port area is called the San Pedro Port Complex. It's the fifth largest container port in the world, and as it turns out, the top container traffic that comes to the port, at least in terms of the dollar value, the top countries are China, Japan, Taiwan, South Korea, and Thailand is the fifth in the value of goods that come through the port. It handles over 40% of container traffic trade of USA, and there was a noticeably large increase in the volume from 9.5 million 20 feet equivalent units. TEU is how the container traffic is usually categorized. They're brought down to 20 feet equivalent container units. So 9.5 million it was in 2000 and went up to 15.3, which, and I believe it was 16.8 or so in 2006. And after that, there was a little economic downturn, and the numbers have gone down to probably 12 or 13. I don't have the latest number, but these are fairly significant increases in container traffic at the port. And associated with that, what interests me a bit more is also the connection. And you can actually see the picture that I'm showing is of the 710 freeway that goes from the port. This freeway that continues on in what's known as the Alameda Corridor with a rail alternative in between and the 110 freeway. The 710 freeway it has the highest truck volumes in the whole world, and you can see that. I have driven on this freeway, so you can imagine how to navigate a car in the middle of all those trucks. So that's the context that we are looking at. Let me first start with motor vehicle emissions, which is the first problem that we face, along with the delays out there, which everybody can very much see. Two types of emissions, as many of you have done atmospheric research, and I'm really not an expert on this topic, but the research that we did was among a group of faculty at the Institute of Transportation Studies at University of California at Irvine. And you have the passenger cars as one group of vehicles that's in the traffic, and they mainly contribute to greenhouse gases. And then you have the trucks and train, diesel-powered vehicles, which tend to cause more problems in public health directly in terms of NO and NOx and particulate matter emissions that happen out there. So the diesel vehicles actually end up causing more immediate damage on the public health and the regular vehicles through greenhouse gas and ozone layer problems, etc. And some numbers on it. Premature deaths in California, in Southern California, up to 5,400 per year caused by diesel vehicles, hospitalization 2,400 per year, et cetera, et cetera. These are problems that are fairly well studied or well known, but their solutions really require transportation research, and that has been lagging behind. Just going back to freight corridor work, what we used to do and what is generally done around the world even now is to do the traffic analysis at a planning level, by which I mean doing your traffic assignment, as it is called. Those of you who look into transportation analysis would have heard of static traffic assignment, which is the idea that you have an equilibrium solution for a network where you cannot find alternate routes with different traffic times, and that sort of planning models are usually done on the basis of a steady state solution out there, and static steady state flows on the links, etc. And you will hear further presentations in the workshop that will clear up some of the details of static analysis versus more detailed analysis, which would be what I would call dynamic analysis, more at the microscopic level, where you don't look at flows as a steady state quantity on the links in the network, but you look at individual vehicles, how they go, how they accelerate, decelerate, how they emit emissions, etc. So that's the microscopic analysis with microscopic emissions. There has been some work in those areas. Over the last 2, 3, 4 years, a group of us researchers, and I've listed some names at the bottom, mainly myself and 2 of my faculty colleagues, Professor Stephen Ritchie and Professor Sean Daniels-Safaris, and a group of students have done a more elaborate analysis in terms of doing microscopic simulation, detailed modeling of every vehicle's movement, with every vehicle's emission separately found out from the simulation, along with a dispersion of emissions modeling, which is a third aspect, which is atmospheric dispersion of these emissions that comes from trucks and other vehicles. A paper that, in fact, I would say there is one more level after the dispersion analysis, which is on the health impacts of the kind of dispersion that happens in an area, which requires meteorological studies on how the wind patterns change in a network, how the emissions from the vehicles get spread over the network, and what kind of health impacts they cause. A paper that we wrote on this, which initially as an academician or as a theoretical researcher, I thought was not a great paper, but it ended up getting picked as the best paper at the Transportation Research Board meeting a couple of years back, and made us go back and look at what we were doing if everybody thought this was great work. It turned out we were actually doing some good work, which we didn't even realize initially. Let me pull back a little and go back to a fundamental issue. As in this workshop, hopefully we can have some of the answers to these kind of topics, or at least have an exposure to these items. Static planning models are poor for emission analysis, which is something that you will hear all over the place, but you don't get an explanation for it. So the planning models that we use, be it TranPlan, TransCAD, ME2, whichever are the planning software that are used by planning agencies around the world for transportation planning and forecasting, those models are usually, in fact, always static models. What's the problems with these models in terms of its ability to predict emissions? And I can bring this down to a very simple thought. In the static models, what is usually done is a cost function that assumes that if there is higher flow of vehicles on a link in the network, you have much higher delay. So if you think of an x-axis of vehicle flows in terms of number of vehicles that